Alright, so in this video, we're going to take a look at some geometric proportions. Right. In particular, we're going to take a look at, well, first let's start off with something called similar figures. Now, notice here the use of the word similar and not equal figures, right? If, let's say, two figures, let's say triangles were equal to each other, then what that would imply is that all the sides and all the angles are equal to each other. All right, now, when we say similar, this is a different type of relationship, where what we have here is in triangles, the angles are equal. Right? But as we can see here, right, just visually, that the sides, they're not equal to each other, right? So the angles will be, right? But in particular, what the sides, so if I call this, let's say A, B, C, and we'll call this D, E, F. The sides are not equal to each other, right? As we can see, A does not equal D, B does not equal E, right? And C does not equal F, right? And these are the corresponding sides, right? The side opposite this angle is B, the side opposite the same angle, right, which is equal is E. So B and E are corresponding, A and D are corresponding, C and F are corresponding, right? They're across those same size angle. All right, now while the sides are not equal to each other, they do come in the same proportions, right? So that means that the ratio of the corresponding sides are all equal to each other, which is really nice, right? A over D, right, is equal to B over E, and is equal to C over F. Okay, now one thing that I want you all to notice here is that in the numerator here, it's all the ones in the smaller figure. Okay, so that needs to remain constant, right? Smaller figure here in the numerator, larger figure in the denominator. All right, and you can choose any two of these, right, if you want to set up just an equation, right, not this three term expression or equality here. All right, you can set these two equal to each other, those two equal to each other, right, or those two, right? Any ratio of the corresponding sides, depending on what you're solving for, you can use. Okay, and again, right, or just to kind of state here, I made a deal about all the smaller sides are in the numerator, right? This was chosen arbitrarily. You can just as easily write the relationship as D over A equals to E over B equals to F over C. Okay, and that is equivalent, right? It is the same, right? So don't worry about which one's in the numerator, which is in the denominator. Just choose the one that you want, right? And then just be consistent throughout the whole problem. All right, so now let's take a look at a word problem where we're going to use a similar figure. Okay, so this states if a 6-foot tall woman cast a 3-foot long shadow. Right, so here, 6-foot woman. Let's say the shadow's on the ground here. 3-foot shadow. And we'll assume this woman is standing up straight. Right, so it's kind of what we call a right triangle, signified by this little square here in the corner here. Then, how long is the shadow that an 18-foot ladder costs? So here, 18 feet, 18-foot ladder. Here, again, the shadow. I don't know how long the shadow is, so I'll call it X foot shadow. Okay. All right. So here, what we have here is we have kind of a similar triangle going on here, right? Right triangles here. right, measuring the same kind of shadow here. So what we can do here is we can write the ratios here. All right, so 6-foot woman, 18-foot ladder. That'll be equal to the corresponding part here, 3-foot shadow. Excuse me. And then X foot shadow, which I don't know, right? All right. So now at this point, again, just make sure we see the corresponding parts, right? 16 and 6 and 18, excuse me, and then 3 and X are unknown. All right, now at this point, this should be pretty straightforward. All right, we can drop the units here, right, to solve. So it really boils down to this. All right, now this is a basic proportion, right? How to solve this at this point should right away see this and be like, oh, this is the easy, right? Which is kind of here, multiply across 6x to 64. Excuse me a second. 54. Excuse me. 54. All right, divide by 6. That reduces to 1. It goes 9. Okay. Now again, when solving an application, all right, we're not quite done yet here, right? We found a number, but we were asked a question, right? How long is the shadow that an 18-foot ladder costs? Cast. So 9, our units should be a 9-foot shadow. Okay, so do not forget this, right? When dealing with a word problem, you're asked a question, make sure you solve it by providing the appropriate context, right? Usually units, right? What are we, 9-foot shadow. All right, and this, always ask yourself, does that make sense with what is going on here? And it does, right? All right, 6 feet, 3 feet, so it makes sense that this is larger, right? The shadow would be larger than 3 feet. All right, and that seems like an appropriate value. Okay.